LangGraph implements an asynchronous streaming mechanism that propagates configuration context through graph nodes, enabling real-time token-level updates from language model invocations. This pattern leverages the messages stream mode to surface LLM output chunks alongside execution metadata, while explicitly handling async context propagation for Python versions below 3.11. We're about to examine a graph configuration that initializes a chat model, defines a state schema with topic and joke fields, and implements an async node function that accepts configuration parameters. The execution will demonstrate streaming LLM tokens through the aStream method with stream mode equals messages, revealing how configuration context flows through the async invocation chain.
From typing, import typed dict. From LangGraph, graph import start state graph. From LangChain, chat models import init chat model. Model equals init chat model equals GPT-4. 1 mini. Class state type dict. Topic, SDR. Joke, SDR. Hash accept config as an argument in the async node function. Async def call model state config. Topic equals state and topic. Print generating joke. Hash pass config to model. Invoke to ensure proper context propagation. Joke response equals await model. Invoke. Role, user, content. F write a joke about topic. Config. Return joke. Joke response content. Graph equals. State graph state. Add node call model. Add edge start. Call model. Compile. Hash set stream mode equals messages to stream LLM tokens. Async for chunk. Metadata and graph stream. Topic, ice cream. Stream mode equals messages. If chunk content. Print chunk, content end equals, flush equals true.
This code demonstrates async streaming with config propagation in LangGraph, a pattern crucial for real-time LLM applications. The implementation uses stream mode equals messages to stream LLM tokens as they're generated, which significantly improves user experience by providing immediate feedback during model inference. The async node function, call model, explicitly accepts and passes a config parameter to model. Invoke, ensuring proper context propagation, a requirement for Python versions below 3.11, where Asyncio doesn't automatically handle context variables. The design choice to use messages, streaming mode, rather than custom mode reflects a preference for built-in LLM token streaming over manual chunk handling. This approach provides structured output with metadata about each token's origin, making it easier to track which node generated which content. The trade-off is that this requires Lang chain-compatible models, whereas custom mode would work with any streaming API. The explicit config passing, while verbose, ensures reliable streaming behavior across Python versions, though it does add boilerplate that wouldn't be needed in Python 3.11+. For production use, this pattern offers excellent responsiveness, but requires careful error handling around the streaming connection. The config propagation pattern shown here is essential for maintaining proper context in async environments, particularly when dealing with callbacks or other context-sensitive operations. The choice to stream at the graph level rather than individual model level centralizes the streaming logic, making it easier to manage across complex workflows. Let's break it down.
From typing, import typed dict.
Imports typed dict from the typing module, which enables creating dictionary-like structures with type annotations for keys and values.
From LangGraph, graph import start state graph.
Imports start and state graph from the LangGraph graph module. Start is a constant representing the entry point of a graph, while state graph is a class for constructing stateful workflow graphs.
From LangChain, chat models import init chat model.
imports the initChatModel function from LangChain's chatModels module, which provides functionality to initialize and configure chat-based language models.
Model equals initChatModel model equals GPT-4 1 mini.
Initializes a chat model instance using the GPT-4 1 mini model identifier. The initChatModel function creates and returns a configured model object ready for conversational interactions, with the specified model serving as the underlying LLM backend. The resulting model variable holds this initialized instance for subsequent use in the application.
Class state type dict. Topic SDR.
Defines a state class using typed dict with a single required string field named topic. This creates a type-annotated dictionary structure where topic must be a string value, enforcing type safety for state management in the application.
Hash accept config as an argument in the async node function. Async def call model state config.
Defines an asynchronous function named callModel that accepts two parameters, state and config. The function is designed to work within LangGraph streaming system, where state typically represents the current graph state and config contains configuration options for the node execution. This signature indicates the function can handle both the processing state and customizable behavior through the config parameter.
Topic equals state and topic.
Extracts the value associated with the key topic from the state dictionary and assigns it to the variable topic. This retrieves whatever topic information is stored in the current graph state for use in subsequent operations.
Print generating joke.
Prints the string generating joke to standard output, serving as a user-facing progress indicator during joke generation.
Joke response equals await model, ainvoke.
Asynchronously invokes the model's ainvoke method and awaits its response, storing the result in the variable joke response. This initiates an asynchronous call to the model, likely an LLM, to generate or retrieve a joke, with the response being captured for further use in the program. The await keyword indicates this is part of an async function, pausing execution until the model's response is ready.
Role, user, content, F write a joke about topic.
Creates a list containing a single dictionary representing a user message with role, user, and content that is an F-string generating a joke request about a specified topic. This appears to be formatting a message payload for an LLM conversation interface, where the topic variable will be interpolated into the joke prompt.
Return joke, joke response content.
Returns a dictionary with a single key, joke, mapped to the content of the joke response object. This packages the joke content into a structured format for output or further processing.
State graph state.
Creates a state graph instance initialized with a state class, establishing the foundation for a state machine where state defines the structure of data that will flow through the graph's nodes and edges. This is the entry point for building a graph-based workflow where state tracks the application's data model throughout execution.
Add node call model.
Adds a node named callModel to the graph. This node will be part of the graph's execution flow and can be invoked during graph traversal. The specific behavior of this node depends on how callModel is defined elsewhere in the code, but this line simply registers it as a node in the graph structure.
Add edge start, call model.
Adds a directed edge from the start node to the callModel node in the graph, establishing that the callModel node should be executed immediately after the graph starts.
Compile.
compiles the LangGraph workflow into an executable graph structure. This method call finalizes the graph definition and prepares it for execution, enabling the streaming capabilities defined in the graph configuration.
Async for chunk, metadata in graph stream.
Iterates asynchronously over a stream of LLM token chunks and their associated metadata emitted by the graph. Each iteration yields a tuple containing the current token chunk and a metadata dictionary with details about the graph node and LLM invocation that produced it.
Topic, ice cream.
Creates a dictionary with a single key-value pair where the key is topic and the value is the string ice cream. This represents a simple data structure that associates the topic identifier with its corresponding value.
Stream mode equals messages.
Sets the streaming mode to messages for token-by-token LLM output streaming with metadata.
If chunk content. Print chunk, content end equals, flush equals true.
Checks if the chunk content attribute exists and has a truthy value. If true, prints the content followed by a pipe character without adding a new line and forces immediate output flushing to ensure real-time display. This pattern is commonly used in streaming scenarios to show incremental output as it becomes available. This implementation showcases LangGraph's async streaming pattern for real-time LLM interactions, where configuration context flows through graph nodes to enable token-level updates. The core technique combines stream mode equals messages with explicit config propagation in async node functions, a necessity for Python versions below 3.11. The call model node demonstrates this by accepting and passing the config parameter to model. Invoke, ensuring proper context handling during async execution. This explicit passing, while verbose, guarantees reliable streaming behavior across Python versions. The choice of messages, mode over custom, reflects a preference for structured LLM token streaming with built-in metadata, though it does require Lang chain-compatible models. When executed via GraphStream, the system streams tokens as they're generated, with each chunk accompanied by metadata about its origin. This centralized streaming approach at the graph level simplifies management across complex workflows, though it does require careful error handling in production scenarios. The pattern balances responsiveness with maintainability, making it particularly suitable for real-time LLM applications where immediate feedback is crucial.
The state whispers a joke to the stream, but the graph only hears silence.